Hello aspirant. This question is from GATE 2018, Mechanical Engineering paper set 1, question number 21. If the wire diameter of a compressive helical spring is increased by 2%, the change in spring stiffness in percentage is dash. So as we know, stiffness of a spring is given as force in the spring upon deflection of the spring. This deflection can be found out using partial differential of energy with respect to force. Spring stiffness is shear modulus G into wire diameter small d raised to 4 divided by 8 into coil diameter capital D cube into number of turns of the spring. Let the new wire diameter be d dash. Now it is given that wire diameter, that is small d, has increased by 2%. So if it is increased by 2%, we can write that it has become 1.02 times of original diameter d. New stiffness will be K dash is equal to G into, substitute the new wire diameter, 1.02 times the old one d raised to power 4 divided by all other quantities remain the same. 8 into capital D cube into n. So we can separate out this coefficient of small d and write it as 1.02 raised to 4 into g d to the power 4 upon 8d cube n. So this is nothing but the stiffness of old spring. So we can write it 1.02 raised to 4 amounts to 1.082 times the old stiffness K. So the new stiffness is equal to 1.082 times the old stiffness. To calculate the percentage change, we will use delta K is equal to change in stiffness, that is new stiffness minus original stiffness, per unit the original stiffness, into 100. Substituting these values, we get 1.082 minus 1 divided by 1. Because k is common in all the terms, we can cancel out the k, into 100. This amounts to 8.2 and this value is in percentage. So percentage change in stiffness after the diameter has been increased by 2% is 8.2% increase in stiffness. So let's fill in the answer here. The change in spring stiffness in percentage is 8.2%. To learn more about springs and stiffness of springs, you can refer to the NPTEL video Lecture 39 Springs 1 by Professor S.K. Bhattacharya. He is from Department of Civil Engineering, IIT Kharagpur. I hope this solution will help you clear your doubt. Thank you.